Okay, we are on to lesson 2.4 for Algebra 1. So this lesson, we're actually going to look at solving equations when we have a variable on both sides. But let's start with our warm-up like we always do. So again, you guys aren't going to learn if you don't try them before I do them for you, okay? So you need to pause the video and do them if you have not. All right, 4x minus 10x. So these are like terms because we have an x and an x. So we look at the coefficient out in front, and that's 4 minus 10, which makes a negative 6, and then we tack on the common variable. All right, for this one, we're going to distribute this negative 7. So we get negative 7x plus 21. Same thing, 1/3 distributed to each. So we could write this out this way if this helps. 1/3 times 6, or sorry, 6 over 1x plus 1/3 times 9 over 1, which becomes 2x plus 3. Okay. Here's our favorite negative sign. Remember, treat this like a negative 1 out in front. So we get 15 minus x plus 2. I'm going to combine that 15 and that 2, so I get 17 minus x. All right, we're going to solve. So I need to reverse order. So first it's the 3 times the x and then the adding 2. So I go backwards by subtracting 2. So I get 3x equals 6. Then I divide by 3 and my x is equal to 2. I'm going to again do the opposite first, add 1/3, add 1/3. So in order to make this a common denominator, I'm going to make 27 over 3. I'm going to convert my 9 to 27 over 3. So then I get 1/3 x equals 27 plus 1 is 28 over 3. Now I'm going to multiply by 3 over 1 on both sides. So I get x is equal to, these 3's cancel, and I just get 28. Okay? Okay, so in this lesson, again, we are going to look at solving equations with one variable, but we're going to see variables on both sides. So you're going to hear the term identity today. When we solve an equation with variables on both sides, we use inverse operations to collect variables on one side, meaning we want to get all the variables on one side of the equation. Just a helpful hint, equations are easier to solve when we have the variable with a positive coefficient. So whenever I choose what side I'm going to put the variables on, I always make sure it's the side that makes me have a positive variable, okay? And just a reminder, to solve more complicated equations, you may first have to simplify, like using the distributive property or combining like terms. All right, so here we go. We've got 7n minus 2 and equals 5n plus 2. So I'm going to get my 5n and my 7n on one side. And the way I'm going to choose this is that I'm going to move my 5n to the other side with the 7n, because I know that I'm going to have to subtract it because it's positive on this side. If I were to move the 7, that would make a negative n on the other side. Okay, so even though there's no sign here, it's a positive 5n. So when I subtract it, I get 2n minus 2 equals 6. Now it's a nice two-step equation. I can add my 2 and divide then by 2. So n is equal to 4. Okay, so again, let me just show you. If I had moved the 7n over, so let's say I'd subtracted 7n. Well, that makes this a negative 2n. And yes, you can solve it that way. I think it's just people get a little more confused when they have to keep track of variables that are negative. All right, so we've got 4. This is a complicated one. And the first thing I see is I see parentheses. That means I'm going to have to distribute, okay? So I'm going to keep everything else the same. I'm not going to touch this side of the equation. I'm going to distribute my negative 5, so that becomes negative 35, and then a positive 10a. Okay? Now I'm going to combine on this side. I've got a negative 6a and a positive 4a, so that makes a negative 2a. On this side, I've got a negative 1 and a negative 35, so that's a negative 36. Okay, so now I've simplified as far as I can on both sides. I want to move actually this 2a over so that I keep my variables positive. So that makes 12a. Okay, now I'm going to add 36 to both sides. So that makes 40 is equal to 12a. Now I'm just going to divide by 12. And it's not going to be a perfect answer. That's okay. It's a fraction, but we can simplify 40 over 12. We can take a 4 out of 40, and we can also take a 4 out of 12. So our answer is 10 over 3. That had a lot of steps, so if you want to rewind and watch how I do that, go back and watch. All right, vocab word, an identity. An identity is an equation that is true for all values of the variable. Okay, so an equation that is an identity has infinitely many solutions. So we're going to come across some where when we try to solve it, the variables like go away and we get the same thing on both sides. That's called an identity, meaning it's all real numbers that are solutions. But if an equation is false, meaning we get something like 18 or 8 equals 21, obviously that's not true. We say that that is a no solution equation. Okay. So just to kind of go over this again, so you need to know the difference of these two. Let's say I have like 2 plus 1 equals 2 plus 1, so that's 3 equals 3. That is what it would look like with numbers. Here's something where it would look like an equation. If you were to subtract the x from one side, it cancels on both sides, and you're left with the same thing, 2 equals 2. With a false equation, a no solution equation, when you go to subtract that x, yes, they cancel, but you're left with something that's not true, so we say this is no solution. And this we can say is infinitely many solutions. You can kind of abbreviate that. Okay? So let's see if we get that. We have to decide if it's infinitely many or no solution. All right? So here we go. I am going to combine my like terms first. So 10 and a positive 1 make 11 minus 5x equal. I'm going to combine my 7x and my negative 12x. That makes a negative 5x plus 11. Well, it doesn't matter which variable I move. If I move that 5x over, let's say I try to move this one. Well, look, it cancels. So I get 11 equals 11. When I get a true statement, remember that is my infinitely many solutions. And I'm just kind of abbreviating. All right, let's try this next one. 12x and a positive 1x makes 13x minus 3 equals 5x and 8x, which makes 13x minus 4. I'm going to move this 13x over, but look, when I move it over, that cancels, and I'm left with my negative 3 equals my negative 4. That is not a true statement, so it is no solution. All right, let's try our word problem. And this is the last little part, so pay attention closely. Word problems I know are not your favorite. John and Sarah are planting tulip bulbs, okay? John has planted 16 of them, and he is planting at a rate of 44 bulbs per hour. Sarah has planted 96 total, and she is planting at a rate of 32 per hour. In how many hours will they have planted the same number of bulbs? And we want to know how many bulbs that will be. Okay, so if this was a problem in your homework, I would suggest writing down information. So you could write John, and then we could put he's done 60 bulbs plus 44 per hour. So he's already done 60, and we know he's going to do 44 more per hour, okay? Sarah, we know, has planted 96, and she's going to plant 32 per hour after this. So we are going to pick up now from the amount that they've already planted. Okay, we want to know when will the 60 bulbs that John has planted plus 44 per hour be the same as the 96 bulbs Sarah's planted plus the 32 per hour. We're going to use H to represent the hours, okay, because we don't know the number of hours. So 60 plus 44 each hour, that means 44 times each hour, is the same as, means equal, 96 bulbs plus 32 per each hour. So we have our equation. 60 plus 44H equals 96 plus 32H. We want to find out when will H make these two sides equal. So let's move this 32H over because I want to have my positive variable on one side. So I get 60 plus 12H equals 36. Okay, I'm going to rewrite this over here so that I have room. I'm going to now move this 60 over. Okay. Oh, sorry, that shouldn't have been 36. This should be 96. I'm going to now move this 60 over. So I get 12H is equal to 36. Now I divide by 12 and I have H is equal to 3. Okay, what does this mean? Let's explain. After 3 hours, we just solved. For after 3 hours, John and Sarah will have planted the same number of bulbs. Okay? We know that at the start, John had already done 60 and Sarah had already done 96. So we want to know how many total has each one planted. To find out how many bulbs they'll planted in those 3 hours, we're going to plug 3 in to the expression to find this out. Okay? So we know that for John, I'm going to use a J. For John, he's going to plant 60 plus 44 times H. Okay. For Sarah, we know she's going to plant 96 plus 32 times H. So now I'm going to plug that 3 in to that H for both of them. So when I solve this out, I'm actually going to get 60 plus 132. 44 times 3 is 132. And then I'm going to get 96 plus 42 times 3 is 96. So this total should be the same. So let's hope that I did my math right. I didn't mess up. 192. And then 96 plus 96 is 192. So after 3 hours, they will have planted 196 bulbs each, which is good. We wanted it to be the same, right? So that was a little bit complicated, I know, but what I can't reiterate enough is after you guys read a word problem, write down what it is, what it wants to know. Write down the information and then come up with a verbal model because that will help you set up your actual algebraic expression. Okay? So again, just a review of this lesson. We want to make sure we collect everything on one side, all our variables on one side before we solve, and then we will work our way backwards to solve for that variable.